So for doing this one, remember, in order to solve this by graphing, we end up setting it up as two separate equations. So I do y equals the left side and y equals the right side, then graph each of those. For that one on the left side, that gives us the U-shaped graph because it's a quadratic. I know that because it has that squared on it. And anytime I see that squared, I know I'm going to get that U-shaped graph. And then, of course, the y equals 9, that's just our horizontal line, and we're good to go from there. Once you've graphed it, it's just a matter of looking for where they cross. And so they cross once here. The x-coordinate there is -5. And they cross once here. Notice our x-coordinate there is 1. And yes, I'm only giving the x-coordinates because you'll notice our original equation only had x in it. So there's no y to give coming out of that part. And so having done these types of problems yesterday, we now can actually start taking a look at how we can solve something that's even more complicated. Because oftentimes when we're looking at these types of problems, where we have a function equal to a number, there are algebraic ways to solve it. Whether we've learned them yet or not, we can solve them algebraically. But it gets a lot trickier when the left and the right side are both functions. And so that's the variation that we're adding on to today's work. So go ahead and write this equation now above your next graphing grid. So in order to do this one, we actually approach it the same basic way that we approached the problems that we did yesterday. We start by breaking it up into two different equations. And so I'm going to have it y equals to the left side, so y equals x plus 6. And then y equals the right side, so y equals the absolute value of x. And so once we have it set up as two separate equations like this, then we can actually graph each one separately with the stuff you already know how to do, right? Like the graph of y equals x plus 6. You can graph that. What's the 6 do to it? It moves it which way? Up, down, left, or right? That one is hanging on the end like that. So that means, yep, it's up. There would have to be parentheses around it for it to move it sideways. And so I'm going to graph that one by moving up 6. And then what's the shape of that first one?
Linear.
Yep, it is linear. That is, it's just going to be a line then. And so I start by going up 6. And then it's just a line. So I'm going to go up 1 over 1 and continue that same pattern all the way along. Put the dots out to the edges, then use your straight edge to draw it in. And then once we've graphed that first one, then we can take a look at the second one, where we have y equals the absolute value of x. Now, anytime we see those absolute value bars, that tells us that the shape of our graph is going to be a V. Now, in this case, you notice there's nothing added or subtracted. And since there's nothing added or subtracted, we know then we're starting at 0, because it's not been moved up, down, left, or right. And then we make our V from there. So that is up 1 over 1 on both sides. And so we graph them, and then we find our solution the exact same way. So to find the solution, we're just looking to see where do the two graphs cross. And in this case, they cross where x equals -3. Now for this one, we're graphing a quadratic this time. So we got y equals x minus 5 squared. Now the -5, it's in with x, right? So that means it's going to go to the right. So that's where our first point goes. And from here, it's a quadratic. That is, we got that x squared aspect to it. So let's just check and make sure that you remember where those points go, because this is one of those things I want you more and more memorizing. Many of you are still using the blue sheets or whatever as a reference. That's fine. But I want us moving towards memorization. So if I go over 1, I'm going to go up 1, because 1 squared is 1. And notice I'm talking squared here because that's the type of equation. Then, if I go over 2 from my starting point, what's 2 squared? 4. So that means over 2 up 4 from that starting point. All right, and then from there we go over 3 and up 9 for the same reasons. Then graph the absolute value. I think you're pretty good with the absolute value. So this is our graph. And then we just look to see where do they cross for our solutions. And so that's how we get the answers of 3 and 7. All right, now this one introduces a square root into our work here, so it's a reminder and a refresher how we do the square root functions. So with the x plus 3 plus 1, for some of you, you still every now and then will get mixed up about which way to go. By all means, draw the arrows on showing which way you're moving, because it can be hard to actually keep track of an equation and a picture in our heads at the same time. And so if you write those arrows on there, it just makes it that much easier to keep track of it. All right, so now for the graphing, I go left 3 and up 1 for my first point, and then it's a square root function, right? So the square root of 1 is 1, so I go over 1 up 1. But at this point, remember we do not go over 2, because the square root of 2 is like 1.414, you know, it's a decimal. We don't have to worry about plotting all these decimals. So instead we go over the next number I can take the square root of easily, which is 4. And the square root of 4 is 2. So we go over 4 up 2. Remember, that's from my starting point. I'm always counting from that first point I plotted. And then as we continue plotting our points here, the next number I can actually take the square root of is 9. So we're going to go over 9 and up 3, because the square root of 9 is 3. And then you draw your curve in that goes through those points. One note on this curve. Notice there's nothing down here. There's nothing that's below that first point. There's nothing that's to the left of that first point. The reason is because the square root of like a -1, if we try to go to the left, doesn't exist. We cannot take the square root of a negative. And so literally from this starting point, there's nothing below it or to the left of it. All right, and then once we have that, then we go ahead and we can graph the y equals x plus 4. And then you'll notice that these two actually cross twice. It can be a little bit hard to tell if we don't remember where the graphs are going and the way they behave. So this, remember, was our starting point for our square root. We then graphed the point here that was over 1 up 1. So remember, we went like this, and then we went like this. Well, if you were graphing this y equals x plus 4 point by point as well, you would start up 4, and then over 1, down 1, over 1, down 1, and so on, in order to get that. That's why plotting the points can be so useful. Every now and then I'll see somebody who will just plot like a couple points and then just kind of sketch in where the line goes. With this one, that could be tricky, right? It can be really hard to tell exactly where it is if we don't take our time with those individual points. All right, now if we actually were able to zoom in on this really close, you'll actually notice that that square root graph is going up and over the line there. And so it doesn't actually touch in between those 2 points, but it does actually touch at those 2 points, where we started our square root and then the over 1 up 1 from there.